So, review from pre-cal or algebra 2, wherever you remember learning this at. We learned in pre-calculus or in algebra 2 sequences and series. Essentially, that's a fancy way for adding up a bunch of numbers. So we learned sigma notation. We learned that 1 plus 2 plus 3 plus 4 all the way up to 100 could be written in summation notation with the sum from 1 to 100 of n. The n is kind of like a function. It's whatever I'm doing here, and since I'm just adding 1 every time, I'm just going 1, 2, 3, 4. So that is sigma notation. So describe this one in everyday terms. Well, let's find out what it is first. What would I get if I put in n equals 1? What would I get if I put in n equals 2? Right? 2 plus 4 plus 6 plus 8 plus 10. How far do I go up? To 20. Does everyone agree? I go up to where the n is 10, which means my second number is 20, or my last number is 20. So in everyday terms, would you agree this is the sum of the even numbers from 2 to 20? That's what it wanted you to do. Write this one in sigma notation. So this is the sum from n equals, I got a delay on my computer here, 1 to what? Of what? Perfect. Does everyone agree with that? That would pop out that set of numbers, that sequence or series of numbers? 2, 3, 4, 5, all the way to 50 added up in sigma notation. More than one way you could write it. As with most of these, there's more than one way you could write it. Okay, good. We could just do n equals 2 to 50. Of n. You could also, if you really wanted to start at n equals 1, you could do 1 plus n plus 1 and start at 1 to 49. I mean, you could be creative, but I kind of would rather not be creative if I don't have to. So this is just a review of sigma notation. It's going to come up when we start talking about Riemann sums, and I just wanted you to be familiar with it. We are not learning sequences and series in this class, so it's more of just a notational thing that you would need to know. If you take Cal 2, you will spend a lot of time on sequences and series. So, as you can imagine, we've been heading toward this. How could we get more exact when we're approximating the area under this curve? For this purpose, let's use right Riemann sums. How could we get better? Teeny tiny rectangles, right? So there's a couple ways you could write it, but let's first talk about the sigma notation for summing this up. So this would be the sum. It doesn't matter. Let's do right, just for fun. It doesn't really. For this writing it out purpose, well, we don't have to assume that. We can be. Okay, so I'm going to do n equals 1. Let's do k instead of n. Why would I use k instead of n? See this little n down here? I'm going to have to use it as a number, so I'm going to use k to n. And I want to sum up those rectangles. I'm going to use the little subscript as a k. So I'm going to multiply f of x sub k. Does everyone agree? The height. And why did I start at 1 and not 0? Because it's a right triangle. Okay. And then if you're equal intervals, you could just do delta x. If you're not equal intervals, you could put a little subscript on here to say delta x at each different one. So that makes absolutely no difference how you do that. This is the summation notation for any Riemann right sum, right? It's just the summation notation. I'm going to go ahead and take that subscript off and assume equal subintervals, but you got options. There are two ways to write the exact or more exact form of that area. And someone said it earlier, it involves a limit. Would everyone agree? The limit is what? N goes to what? Infinity. Does everyone agree? The other absolutely correct way to say that is the limit as delta x approaches 0. Why would that be the same thing? Right, if changing x is small, you get more rectangles. You get more rectangles, changing x is small. It's kind of a... So that's what our goal is to learn how to find that value tomorrow. Okay, so this is some more formulas. Notice, now they used I instead of K. Don't get, I should have used I, didn't remember what letter the next slide used, sorry. Why did they start at I equals 0 and go to n minus 1 for a left rectangle approximation? Yeah, the left-hand height would be at 0, and the right-hand height, the farthest left-hand height would be at n minus 1. We just did a right rectangle.
So if we had, if those are all numbered, whatever the top number say that's x, where the x n minus 1 said that was 8, that would be the top number would be 8.
Right.
It wouldn't be like 9 minus
1. Well, it would be the 9th x value, or the 8th x value. Yeah. Which could be different depending on where you're going, but the exact area, now they did the limit as the length of the partition goes to 0. That would be delta x going to 0. Then they rewrote it as n going to infinity. So we have options.
So the one we wrote down was for the right ram?
We wrote down right ram. Whoops. Yes, we can. Let's try that again. These two things are completely equivalent. The integral from a to b of f of x dx is equal to that infinite sum. It should kick off. Down at 60. Hopefully it'll kick off eventually. No, if it actually gets down to 62, we can kick it back on. So those two things are completely equivalent. Every now and again, and it has become more and more rare in AP, every now and again they will give you a question in summation notation and ask you to find the integral. But you have to understand the summation notation. It is a rare question type, but it occasionally shows up. So that's what we're going to look at on this slide, is just how to pick out what integral this represents. We are going to find a way to calculate that pretty easily tomorrow. So here's some examples of questions that use summation notation. They are little, so I will kind of help read them to you. I don't know if I can, yeah, I can't make it bigger. So, the first one says, which definite integral can be expressed by the limit of the length of the partition going to 0 of the sum from k equals 1 to n of f of c sub k times delta x sub k, where p is any partition on the interval a to b. So we got to figure out what integral that is representing. So the first thing we just need to do is kind of take some fear out of the notation and remind ourselves what each piece meant. They use c instead of x on their c sub k for the place of the partition. However, isn't this thing here just f of x? This thing in here is just some function x. So I am taking the integral of some function x with respect to x. So I'm looking for f of x dx, which means I could be this one or this one. This one says f prime. My summation didn't have a prime in it, so it's not going to be a prime. My summation didn't have a capital F in it, so it's not going to be a capital F. It's whatever that function is. That's the height of each rectangle. I got that from the function. So f of c would be a constant, and so we don't want to replace a function with a constant. This one is trying to trick us here a little bit with the f of c, but it should be the same variable as the dx in your function. And notice this delta x here kind of helped us out with that. This one says from a to b, and oh, sorry. This one says from a to b, and this one says from b to a. Which way do we integrate? A to b, right? We go lower limit on bottom, upper limit on top. And so they tried to trick us there by switching those limits around. How do I know which one's the lower limit? It says I'm finding the area from A to B. So that's question 1. Little different. Which definite integral can be expressed as the limit as the partition goes to 0, the sum k equals 1 to n of 6c sub k squared plus 4c sub k times delta x, where p is any partition from 5 to 12. Well, what you don't see is an f. Why don't you see an f? Like you don't see an f of something. Why not? They actually give you the function. So f of x is evidently 6x squared plus 4x. Because remember, those c sub k's are just our x values. Does everyone see that? Okay, so that answers one question. What am I looking for down here? So it's either that one or that one. Any questions so far? And then I'm going from 5 to 12, not 12 to 5. So it's got to be B. Any questions about that? So you pick out the function, pick out the limits, and that's how you would transfer. You will never have to work a problem from summation notation. The worst case scenario is you'd have to change it into integral notation so that you can work it. So that's nice to know. Which definite integral can be expressed as the length of the partition going to 0 of the sum of this mess? How'd you get E? Hold on, E? Yeah, okay. What'd they do weird on E? They took out a 2. So we're looking for the function 6x plus 4 over 3x squared plus 4x. And we are going from 0 to 10, right? And so at first glance, I want to pick this one, but it's from 10 to 0 instead of 0 to 10. So this is a really tricky one, trying to get me. E is also tricky, but they've done a different trick on E. They factored out a 2. Could you do that? Would a sum be the same if you took a 2 out and then multiplied everything by 2? Can you do that with addition? You can factor out right? So, sure. Which brings us to what we're really learning today, and that's some properties of integrals. If an integral is truly a sum, then it would function like a sum. Now, the first thing we need to note, and this one is a little different, is the order of integration. This is not something you would probably pick out on your own. If for some reason we are going from B to A instead of from A to B, what that does is makes the integral negative. Now, to make that make sense to you, I want to talk about velocity for a second. You remember if we have a velocity curve and we find an area under it, we get the accumulated distance we traveled. If we integrated backwards, wouldn't we undo that distance? So we would subtract the distance instead of add the distance because we are undoing how far we went on that curve. So the integral from b to a of f of x dx is equivalent to negative the integral from a to b of f of x dx. So this is what your homework mainly looks like tonight. You may have one or two summation problems, but this set of rules is where we need to start.
So anytime we have like where it's going to A to B and you know it needs to be to B to A, just
So you're always going to integrate left to right because that's what makes sense in your brain. You're going to find the area left to right. But then if it asks you to do it the other way, you're just going to tack a negative in front of it. What's the integral from a to a and why? I mean, it tells you, but why? Why would the integral from a to a be 0? Yeah, you're not going anywhere, right? If I'm going from a to a, how much area do I accumulate if I don't go anywhere? None, right? Makes sense. But it's a property we need to know. You just figured this one out, the constant multiple rule. If you have a constant times a function and you do the integral, that's the same thing as if you factored out that constant. The reason that is because an integral is just a big sum. And so we can factor out a multiplier and a sum if it's with every term. Same thing with a negative. You could factor out a negative. Sum and difference. If I am adding up f of x plus g of x, and then adding all the areas, wouldn't that be the same as if I did the area under f of x and then added it to the area under g of x? Again, because of properties of summation. Subtraction would be the same way. And we're going to talk about additivity. But while I am on sum and difference, I want to talk about what's not up here. And you need to star this in your notes. What is not a property? The integral from a to b of f of x times g of x is not the integral of f times the integral of g. Okay? There is not a product rule for integration. Why not? Well, if we looked at an area and did a multiplier, that's another function that's going to change things on whether we do the area first or the multiplier first, Does that make sense? Because area is so much bigger after you multiply the height. It's not just by a factor of the height, because you get height times the width factor in there. So this is not equal to F times G. Okay. Not the same, not a property. Division is not a property either. So what you need to know, write it down. We have no properties for multiplication and division.
Can you like rewrite that again?
Yeah. I would rather not, because it's not a property. You know what I mean? You don't need to know what it says. What you need to know is there is no property for multiplication. It does not exist. You know what I'm saying? What I'm saying is a lot of people take this property, the plus and minus one, and try to translate that into multiplication. And it doesn't work. Okay? So that's the gist. I'm going to erase it because it doesn't exist. Wasn't that in this? No, that was in my other class. I was about to say we were talking about not breaking rules and not making up rules, but that was in properties of logarithms. Same thing with properties of integration. If it's not on the list, don't make it up. Okay, any questions about those properties? Product is not a property. Quotient is not a property. We did have a product and quotient rule for differentiation. We do not have one for integration. In fact, that will be the most difficult part of integration, is that we don't have properties for products and quotients. We'll figure some things out. Okay, additivity. This one is really important to show you a picture. It makes so much more sense when you see a picture. If I find the area from A to B, and then I find the area from B to C, what should that be the same as? The area from A to C. Makes perfect sense when I draw a picture, doesn't it? AP will rearrange this sometimes. Sometimes they will give you the integral from A to C and the integral from B to C and ask you to find A to B. How would you do that? Subtract. So that's the last property of integration. Yes? Then it would work the other way, where it would be the integral from A to C plus the integral from...
So they would never say...
Right. Yeah. Normally they will put actual numbers there. Like the integral from 1 to 2 and the integral from 2 to 3 is this. What's the integral from 1 to 3? Something like that. Like this. Okay. These are some questions that they could ask. So notice, and these are not AP problems because they're not multiple choice. So you can see how these could easily be modified to be multiple choice questions. Suppose the integral from -1 to 1 of f of x dx is 5. The integral from 1 to 4 of f of x dx is -2. And the integral from -1 to 1 of h of x dx is 7. Answer the following questions. Okay, so part A. Find each integral if possible. So, start with A. Has anyone figured A out yet? Why?
Because 1 to 4 is -2 and then backward 4 to 1.
Okay, so I want the integral from 4 to 1 of f of x. I don't know the integral from 4 to 1 of f of x, but I do know the integral from 1 to 4 of f of x. And what do I know about those two integrals? Look back at the last slide. They're just opposite signs. The limits are switched, which means the answers are opposite signs. Does that make sense, Addison? Are you sure?
Oh yeah, it's just,
Okay.
I don't write that down.
You could print it later if you would rather just. I would go back and print it or copy it later, but you can. The integral from -1 to 4 of f of x dx. I'll give you time to think, so don't answer yet. Any ideas? Think about, see if you can answer that. Okay. Any thoughts? Why? Very good. Additivity. This integral, remember, think area. This integral gives us the area from -1 to 1. And this integral gives us the area from 1 to 4. If I want the area all the way from -1 to 4, I would just add those up. So 5 plus -2, which is 3. Any questions about that one? The next one involves two different functions, but the limits are the same. What can I do with two different functions added together? I can split them up. Not only can I split the pieces up, but I can also take out the constants. True? So what's 2 times the integral of f of x from -1 to 1? What's 3 times the integral of h of x from -1? And so that answer is 31. This takes some getting used to. However, at this point, are you excited that these show up on AP problems? They're not horrible. We got to learn the properties and memorize the properties, but so far so good. Integral from 0 to 1 of f of x. Do I have a property to half an interval? Not unless it said something about f of x being even or symmetric with the other. So on this one, I don't know. So it says if possible. So I would say not possible. I can't find it. What about h of x from -2 to 2? I don't know that. F of x plus h of x from -1 to 4. Not possible. Because, why not on the last one? For h of x, now f of x I could do, but for h of x, I don't know the integral all the way to 4. I only know the integral from -1 to 1. Any questions about those? You try this next one. The multiple choice problem. See if you can do multiple choice. Any multiple choice problem. It's a tough one. It is due tomorrow. not that many problems. And I think this is my last slide, so you may even have yeah, it's my last slide.
So we're supposed to do on the end of page 286.
Yeah. Okay, let's do this one. If the integral from 1 to 10 of f of x dx is 4, the integral from 10 to 3 of f of x dx is 7, then what's the integral from 1 to 3? The first thing I would do is note the improper limits, right? I've got from 10 to 3 instead of from 3 to 10. That's going to hurt my brain a little bit. Does everyone agree with that? So the first thing I'm going to note is that I know the integral from 3 to 10 of f of x dx is what? -7. Which is good to know. What do you know about the integral from 1 to 3 and the integral from 3 to 10 of the same function? They add to be the integral from 1 to 10. So there's a couple ways you could think about this. You could rewrite the additivity property, or you could think about, it's up to you how you do that, but I know that this thing that I don't know, plus -7 equals 4. Does everyone agree? The integral from 1 to 3 plus the integral from 3 to 10 equals the integral from 1 to 10. Any questions about that? So 11. Everyone agree that x would have to be 11? What plus -7 is 3? Or is 4, sorry? Any questions about that one? Additivity.
Just thought of it as like 4 plus 7. It's like, or like 4 minus -7.
Yes, perfect. You could have also just rewritten the additivity and used 4 minus -7. Yes. Did everyone hear her question? And yeah, there's a lot of different ways you could think about that. As long as you are using the additivity principle, you'll be good. True or false? If the integral from a to b is greater than 0, then f of x is positive for all values. Quick vote. How many of you vote true? So, false? How many of you have no vote? Okay. So let's draw a picture. I do agree that if f of x is positive, then the integral is positive. Question is, does it mean it's not if f of x is negative occasionally, right? So I'm going to draw a quick picture. If I do the integral there, I'm going to add all this area, right? And I'm only going to subtract this little bitty bit of area. That's still going to come out positive. Just because the integral is positive doesn't mean f of x was always positive, right? So the converse of the statement I said earlier is not true. So false. Why? What's my justification? And you don't have to be fancy with calculus. Just use regular words. It'll be fine. Yeah, as long as the positive amount of area outweighs the negative amount of area, the integral will be positive, even if the function occasionally is negative. Does that make sense? So that's a perfectly good justification. If f of x is positive, then the integral is greater than 0. That's true because there is no negative area, right? Now, They could try to trick you by putting from B to A or something, but they didn't. You see, it still says from A to B. So they didn't try to trick you with that, so that's true. Okay.
So if you were to go backwards, it would be negative. Like even if everything's above.
That's right. We'll change the sign.
So if you went backwards and it was negative, it'd be positive.
That's right. And think about it, the logic behind that is if you think about velocity, if you went backwards, but then you undid that area as if you hadn't done that, then you would go back forwards. Negative backwards would be forwards. Does that make sense? It's kind of a strange thought, but the applications make sense. Okay, if the integral from 2 to 5 of f of x dx is 18, how would you do this? What's the property here? Addition. So I'm going to split it up. That's what the property says to do, right? And I feel like I might be stuck because I don't know how to integrate yet. So maybe I'm stuck, or maybe not. Okay, so this answer is 18, right? So the question is, what's this? I do not have anything except geometric methods as of now, correct? So what do you do if all you have is geometric methods? What's geometric methods mean? Right, adding squares up, finding the area, right? Luckily, what does the function 4 look like? Can I find the area from 2 to 5? Oh, okay. So it looked like it was going to be horrible because I don't know a way to do that integral algebraically yet. But they picked a function that I could use rectangles on, luckily. So 3 times 4, which is, so 30. Okay. You have 5 minutes left in class. Do not waste it. Work on the worksheet. Start a couple problems. I'll talk about that tomorrow. Yes. Come to my desk. I don't want to spill the beans for tomorrow's lesson.